think I'm going to share it with you. Hold on a second. There we go. All right. So take a second and read through this program design practice 2. And then what I want to do today is just kind of work through this. And that'll be it. We'll probably have a short class today because I don't think this problem is going to take too long, and I don't have anything after that. So see what you can do with this, and then we will talk about it. Okay, so everybody understand how the system works. We have a chamber, an incinerator, we have a flame, we have a valve here that injects the toxic waste. We have a valve here that injects or actually that controls the flame. And so this is what we're controlling. And then we have these sensors down there. We have these multiple redundant switches, sensor A, B, and C. One of those sensors is an optical sensor, one is a thermal sensor, and the other is an ionization sensor. And so if you read the problem description, what we want is we want proof that the flame is actually in the chamber that is lit. If the flame is not there, you can inject poison or viruses into the chamber and they could escape into the environment. And so what they asked us to do was design the logic control to control the fuel inlet valve. And we want multiple sensors, at least 2 sensors to say true before we determine that the flame is actually there. So make sure you read the problem statement and see if you can go ahead and follow the steps that we have written. Here's the second page, but I didn't want to go to that yet. I don't know if you guys have control over these pages or not. So go ahead and try to work through the problem. First thing you'll do is you'll make your list, calculate your number of rows and all of that. And then we'll look at the truth table in a couple minutes. So see what you can come up with for a truth table.
The description of the problem makes it sound like they don't want it to be on if all three sensors detect a flame. I assume that if all three detect a flame, it can still be on.
I feel like you might need to make like a whole other rung for that, and it might be kind of redundant if you already have like a few rungs that where if two of them are working, then it'll be fine.
Oh yeah, that's a good point. Well, I was just trying to put it together on the truth table, where when you're making the rungs, you probably wouldn't need an extra one for the truth table. I'd assume that all three being on would leave it as on.
Oh, I didn't know I was muted again. I'm sorry. Well, I said I agree that you do want the row where they're all three on, and I don't think there's any redundancies with that one. So this one here will be closer to what you'll have on your final exam. I might add an extra variable. I don't know, it might be four, but it'll be something akin to what we're doing right now. So, like I said, it's pretty simple. You can go through these steps and you understand what we'll do on Monday. I think you'll be in good shape. I'll give you a couple more minutes and then we'll compare our truth tables. Now, guys, he doesn't explicitly say in the problem, but you want to minimize a Boolean expression, which means you got to K-map this. So I don't think anywhere in the description, the steps here where they ask for a K-map, but you always want to show the minimized logic. So when you get your truth table, to get your expression, you want to use a K-map to minimize your truth table and then show the final expression. Here's my truth table. So somebody had a question about this one where they're all three true. And like I said, since that does fit the criteria, even though they say if and only if, I think it's only logical to include that row of the truth table. Anybody group it? How many groups are in the K map? Anybody group it yet?
I had 3 groups.
3 groups. Anybody else have something different? Your map look like that?
Yep.
So I think he's right. There's 3 groups. Okay, so here's our 3 groups. Minimized statement for valve AC or AB or BC. Now you probably could have, if you thought about this long enough, you probably could have arrived at this without going through the steps. But again, I'm not really concerned about the complexity of the problem right now. I want you to see the tools, see the steps, and be able to apply these steps to the problem I'm going to give you for your final exam. So I think hopefully this is pretty clear. It's not rocket science. Once you see how the pieces of the puzzle fit together, then it should be pretty simple. So here's a final step here, and then we're good to go. Pretty straightforward. Anybody questions, comments about this problem?
So we're not including the flame or like the fuel valve, the fuel inlet as an input or an output.
Yeah, they just said that your logic control is controlling the valve for the flame. I mean, we could have done some logic for the other valve, but that's not what this description asks us to do. So we're just interested in the multiple redundancies to control the flame.
So are we talking about the waste shutoff valve then?
Yeah, we're talking about. Wait a minute. We're talking about this valve right here. Wait a minute. Yeah, we're talking about this valve right here. I'm sorry.
Okay.
I guess
Does
they
it
could
say
have.
that in the
It says
description?
shuts off. It says shuts off waste valve. I guess it could have been in the gray box. It could have been a little bit clearer, but it says if no flame is detected. So our logic, they didn't ask us to do any logic control with this. I think I said that in the beginning, but yes, it's the waste valve. So again, the idea here is to just see how the K-map, the Boolean expressions, truth tables, they didn't ask for any gates. That doesn't help us here, but to kind of see how the puzzle kind of fits together with this stuff. And on the exam, I will say that the level of difficulty will be pretty similar to this one. I may add another variable. So instead of having 8 rows in your truth table, you have to add an additional variable, which will give you 2 to the 4th, give you 16 rows, and your K-map will be a bigger K-map. So that's a possibility. But as far as the difficulty level, this is pretty straightforward. You'll have something, and that won't be the only thing on the exam, but everything on the exam will be stuff that we've covered since our lab. So if you've looked at these practice problems, if you understood K-mapping and, your gates and that kind of stuff, you'll be in good shape for your last exam. Speaking of exams, I was kind of surprised that nobody has sent me a link to their exam 2 yet. I don't know. I know I talked to a couple people by text, so I know you're working on them because I've been asked questions about it. But what I'd like for you to do, if you can, try to get that out the way, because you got to send me a link. You text me a link. You can actually text me the video, or I would prefer if you upload it to YouTube and text me a link, and I'll go in, and then in the description, you'll just describe your program, show your logic, make sure you take a video of your logic and the actual program in action, and I'll grade it right from that video. So far, nobody sent me a link yet. So try to get that out the way, because you got your report due next week, and then I want you to focus on exam 4 stuff, which, as I said, if this makes sense to you, if the practice problem we did in last class makes sense to you, and if what we're going to do on Monday makes sense to you, I will say that you know enough, you'll be fine for exam 4. So try to get those other ones out the way, at least the garage door program, just in case you have any issues with your program, you'll have time to correct it. Anybody else have any questions on or comments on this problem, or the exam, the one that's coming up, or anything I posted? Any questions in general? Because this is it. I don't have anything else. We got one more practice problem to do and a PowerPoint. I think I want to hold off until Monday to do that. So does anybody have any questions on anything up to this point so far?
When is exam 4 happening?
Well, I got people going out of town. I'm thinking I'm going to make it available probably right after class on Monday. Well, I'll say Monday or Tuesday. It won't be due until the 9th. And exam
Okay.
4, I think I mentioned this before. I'm not sure. It's something that you'll download, you can work on it, and then you'll upload. It's not one of those time multiple choice like your quizzes. It's not like that. You'll download it, you'll work on it, and you'll submit it by midnight, August 9th.
Okay, thank you.
Is that the only question? Everybody else okay?
Can you show the second page of this document again?
Yeah, this one.
Yeah.
I think you want to go ahead and get that other stuff out the way, and then just get this class, over with and done. I think you guys are taking some other, I forget the other course, that machine design or something, and you can just focus on that, because we'll be done. I think we'll be done Monday. I interrupted somebody. You told me to show the second page. Do you have something to say about the second page or question?
No, I was just wondering if you had the truth table and the relay ladder logic on there somewhere.
Say that again.
The truth table and the relay ladder logic.
Oh yeah. I'll find that one. Hold on a second. This one.
Yeah, that's the one.
Well, guys, that's it. I mean, I'll stick around. I don't have anything else. I mean, I do, but I think I want to wait till Monday, because we'll do one more of these, and on the one that we're gonna do on Monday, I'll give you the assignment, and then you can kind of do it, and I'll post a solution to it. I won't say a lot about it. I do have a PowerPoint, one final PowerPoint I want to go over, and then one document, and I think we can end it. I don't have anything after that, so we probably won't have to meet Wednesday or Friday of next week unless something comes up. I will just kind of check in and make sure you guys, you're okay. But I think we can call it a semester after Monday's class. So if anybody has anything else, any questions or comments, you can send me a text. So I'm done for today. I will stick around though in case anybody has questions or comments. You guys have a great weekend.
Thank you. Have a good one.
Thank you. Appreciate it.
Yep. Thank you.
Guys, see you later.
I have one question. It's just like a
Sure.
small thing. How would you set up a 4-variable truth table? Because I know you do like every other for 3, and then every other 2, and then every other 4, or like after 4 for A. So like this example here. But how would you do it for 4 of them? For like a 4-variable truth table?
Yeah. Well, I'm assuming nobody has a question on this. I'm just gonna go to the camera. And we'll just put that on the board. I feel like I'm helping you with your final exam, but that's okay. You asked the question. You will get an answer. So you want to know, as far as like how you would number the rows?
Yeah, just how to number it correctly so I don't get any duplicates or I don't miss one. Like,
Yeah, so we'll go A, B, C, D. You start with zeros. And we're gonna need 16 rows. So we got 1, okay. So we got 16 rows. Start counting zeros in the first row, and then every bit, and then this is every 2 bits. And then it goes by power of 2, so this is every 4. So this is 0, 0, 0, 0. And this will be every 8. So 8 zeros and 8 ones. And if we got bigger than that, then it would be 16 and 32. But once you get above 4 variables, you got to have like some kind of chart or something to keep things nice. It just goes by power of 2. So every bit, every 2 bits, every 4, and alternate every 8, 16, and so forth.
30. Okay.
I'm not going to give you anything over 4 though. That would be cruel.
Yeah, I get up to like 64 rows really fast.
Right. All right. So once you get over so many variables, you just got another computer. There's programs that will do this for you.
Cool. Well, I appreciate it.
Yeah. Thank you. Anybody else out there that needs to, let's see who we got out there. We got Evan, Jack, James, Caden, Casey, Logan, Tate, Ryan.
I'm a little confused on how you know which of those comes out as true or not.
Are you talking about the
like if we go back to our example with just the 3 variables, like I think the last 4 or 5 were true, but I'm not sure how we came to that.
What do you want me to go back to the problem that we worked on today?
Yeah, so just the truth table for the problem we worked on today.
Okay. So that one.
Correct. Yeah. So like, I'm not sure how we got which ones came out as true or not.
Oh, okay. I see what you're saying. So if you go back to here, and then you go to here, and when you read that, it tells you that in the statement here that they want that waste valve to open if it says if and only if right here 2 out of the 3 sensors detect a good flame. So we need at least 2 truths in there. Now somebody pointed out a valid point that when you go to the truth table, let me go back to the truth table. When you go back to the truth table, what we do is we look for anywhere in the truth table where there's 2 ones, where 2 of the switches are actually true. So that would be here, this one, and that one. So we got a 1 there, these 2. And if you read the problem where they say if and only if any 2, it makes you think that you only want to put a 1 in those rows that I have highlighted. But it only makes sense to put 1 in that row too, because even though all 3 of them are activated, it still fits the criteria of at least 2 being activated, 2 switches, 2 inputs. Even though it says if or only if, it only makes sense to put the 1 there. So we got these 1s over there because the problem statement said that we need our output to be a 1 or to be true when at least 2 of the inputs are true. So everywhere we see 2 1s, then we put a 1 over here in the output. That makes sense?
Yeah. I get that now. Thank you.
Okay. Thank you.
I got a quick question about the garage door simulation.
Okay.
You said that for requirement 5 that you wanted us to add something that we didn't discuss in class. I was doing some Googling and for a while, and I couldn't really figure out. Um, like, is there a place that has like information about what each of the different instructions do and stuff? Because I was trying to Google that, and I was looking on forums and stuff, and it was just people talking about it, but it didn't really. I couldn't find anything that actually explained each instruction.
I think what I found the best resource, the very best resource is actually YouTube. And make sure that when you search YouTube, you actually put in Logix Pro simulation. There's
Okay.
a ton of them out there. Matter of fact, you'll probably find solutions to some of the, like if I had given the traffic simulator, all those solutions are already on YouTube. I mean, I really shouldn't say that, but
Yeah, I mean, we're at this point now, right?
Yeah. So yeah, you'll find a ton of information, and just pick something, just pick something easy. Like, I mean, I don't know, just you got comparators, you got adders, you got it could be, I mean, it could be anything. You can count the number of times. I had somebody use the greater than less than to do some kind of feature, so it doesn't have to be anything, super complex. It just wants you to look at least one other instruction and kind of make it work with the garage program. So pretty much anything you're gonna choose, as long as it makes sense, you'll be all right.
Okay, cool. Thank you.
Guys, have a great weekend. I'll see you on Monday. We'll have our final class on Monday, and then you can just focus on your exam 4, and we'll call it a semester. I'll see you later.
Have a good one.
Thank you.